Hi students, welcome back. So in this session we are going to continue the remaining problems in exercise 3.7. So let us begin. So we should start with the seventh sum word problems on linear equations, right? So seventh one, at present Tainmuri's age is 5 years more than that of Murali's age. 5 years ago, the ratio of Tainmuri's age to Murali's age was 3:2. Find their present ages. So this is the question. So first step is to convert the statement into a linear equation, then find the solution for the linear equation. So that is what we have learned in this exercise up to now, and we are going to continue the same. And here in this question we have to find the present ages of Tainmuri and Murali, and the clues are given as statements. So let us go to the solution first. Let present ages of Tainmuri and Murali be T and M. T for Tainmuri and M for Murali. So this is be denoted as the present ages of Tainmuri and Murali. Now the first statement is said that Tainmuri's age is 5 years more than Murali. Okay, so Tainmuri T is 5 years more, so 5 years more than Murali, that is written as M plus 5. That is the equation. T is equal to M plus 5. That is the equation formed using the first statement. Now they are talking about 5 years ago. The ratio of Tainmuri's age to Murali's age was 3:2. So now we are going to move to the time, which is 5 years ago. So 5 years ago Tainmuri's age would be T minus 5. Since we have taken the present age as T and it is 5 years ago, so it is backwards. So we are subtracting the current present age with minus. That is T minus 5. And Murali's age will also be M minus 5. It is 5 years ago. And what is given? The ratio of the ages will be 3:2. So what I am going to do is, 5 years ago the ratios were like this. So the age and the ratio we are going to equate. So age is T minus 5, that is of Tainmuri, by M minus 5, that is of Murali, are in the ratio 3/2. Now I am going to cross multiply. So when cross multiplying, it becomes 2 into T minus 5, that is equal to 3 into M minus 5. Expanding the brackets, 2 multiplied with T and 5, it becomes 2T minus 10, and 3 multiplied with M and 5, it becomes 3M minus 15. Now what I am going to do is, here in the place of T I am going to substitute M plus 5, so that my equation has only one variable. So in the equation I am going to make that as an equation having only M. So wherever there is T, I am going to substitute M plus 5. So in the place of 2 into T, so 2 into M plus 5 minus 10, that is equal to 3M minus 15. So I have written put T is equal to M plus 5. Now multiply 2M and 2, 5. 2M plus 2 into 5 is 10 minus 10, that is equal to 3M minus 15. So plus 10 minus 10 gets cancelled, and 3M is transposed to the other side. So 2M minus 3M, that is equal to minus 15. 2 minus 3 is 1. So balance you have minus M, that is equal to minus 15. Multiplying throughout with minus, so minus into minus becomes plus. So both the sides LHS and RHS becomes positive, making M is equal to 15. So M denotes the present age of Murali. So I have found out Murali's age as 15. Now I have to find what is Tainmuri's age. So now I am going to take the M is equal to 15. I am going to substitute the value in T is equal to M plus 5. So where there is M, I am going to substitute 15. So T is equal to 15 plus 5, that is 15 plus 5 is nothing but 20. Therefore, Tenmuri's age is 20 years and Murali's age is 15 years. Okay, next. A number consists of 2 digits whose sum is 9. A number consists of 2 digits whose sum is 9. If 27 is subtracted from the original number, its digits are interchanged. Find the original number. So first we are going to form the equation using the given clue. Since there are 2 digits, we are going to take the ones digit or the unit digit and tens digit. So let the unit digit of the number be u and tens digit of the number be t. Okay, a number consists of 2 digits. So ones, a unit digit and a tens digit. So we are taking unit digit as u and tens digit as t. And the first clue is given that when you add them, the answer is 9. So first, what is the format you will write? Tens and units, right? Units at the back and tens at the front. So you will write less tens plus units. When you add, it becomes 9. Now this is the first equation. Second statement says that if 27 is subtracted from the original number, the digits are interchanged. Okay, so if I am going to subtract 27 from the original number, the digits may be interchanged. Now, how am I writing this number? This number is written as 10t plus u. Now, I'll explain how I'm getting this. Suppose I'm taking a 2-digit number 21. 21 is written as 2 into 2 is in the tens place. So 2 into 10 plus 1 in the unit place. Yes. So 21 can be written as 2 into 10 plus 1. We have learnt expansion in our lower classes, right? And similarly 32 can be written as 3 into 10, which is 3, which is why we have written 3 in the tens place. 3 into 10 plus 2 in the units place. Similarly, tu can be written as t into 10 plus u. Right? So that is how I've got 10t plus u. Okay, so this is the number, and if I subtract 27 from the original, from this number, the digits are interchanged. That is what the second statement. So when 27 is subtracted, digits are interchanged. So what is the number I've written? 10t plus u. When I subtract 27, that is minus 27, then the digits are interchanged. That is, the ones and units numbers are interchanged. So what is the answer? 10u plus t. That is the number after interchanging. Okay, 10t plus u becomes 10u plus t. Now we have framed the equation. Now I have to transpose the numbers and make all the like variables together and the constant terms to one side. So what I am doing, by transposing and bringing all variables together, we have 10t minus t minus 10u plus u is equal to 27. So 10t minus t becomes 90, and minus 10u plus u becomes minus 9u, and this 27 remains the same. Now throughout the equation, 9 is common. Yes, so divide by 9 throughout. So 90 by 9 minus 9u by 9, that is equal to 27 by 9. Cancelling becomes t minus u, that is equal to 3. That is the second equation. Now I am going to solve equation 1 and 2. What is the first equation? T plus u is equal to 9. Second equation is t minus u is equal to 3. So here u is eliminated, plus u minus u is eliminated. So you are having 2t is equal to 9 plus 3 is 12. Therefore t is equal to 12 by 2, that is equal to 6. T is the tens place, you have the number as 6. Now put t is equal to 6 in 1. The first equation is t plus u is equal to 9. So in the place of t, 6 plus u is equal to 9. Therefore u is equal to 9 minus 6 and u is equal to 3. So in the tens place you have 6 and in the units place you have 3. Therefore the number is 63. Next sum. The denominator of a fraction exceeds its numerator by 8. If the number if the numerator is increased by 17 and the denominator is decreased by 1, we get 3 by 2. Find the original fraction. So we are going to talk about a fraction number, and the clue is given that the denominator of fraction exceeds its numerator by 8. So first let me take the numerator and denominators as numerator n and d for denominator. The first statement, denominator exceeds numerator by 8. Therefore d is equal to, d is denominator exceeding numerator by 8. So n plus 8. That is the first equation. Second equation, if the numerator is increased by 17, so n plus 17, and denominator is decreased by 1, d minus 1, we get 3 by 2. That is what I have written, n plus 17 divided by d minus 1, that is equal to 3 by 2. So now I have an equation, I have to cross multiply this. So cross multiplying, it becomes 2 into n plus 17, that is equal to 3 into d minus 1. Expanding, 2 into n, 2n, plus 2 into 17, 34. That is equal to 3 into d, 3d, minus 3 into 1, 3. Now I am going to take the constant term on my left hand side, that is 34, and 3 transposing becomes plus 3, that is equal to 3d minus 2n. So therefore we have 3d minus 2n, that is equal to 37. Now here in this second equation I am going to substitute the value of d in 2. Therefore 3 into, in the place of d it is n plus 8 minus 2n, that is equal to 37. So 3 into n is 3n, plus 3 into 8 is 24, minus 2n, that is equal to 37. 3n minus 2n becomes 1n, that is equal to, transpose 24 to the other side, becomes 37 minus 24. Subtracting, it becomes 13. So I have found what is the numerator. It is 13. Now I have to find what is the denominator. So in the first equation, let me substitute what is the value of n. So d is equal to 13 plus 8, that is equal to 21. So now I have found the numerator value and the denominator value. So I just have to write the fraction. Therefore the fraction is n by d. N is numerator, d is denominator, that is equal to 13 by 21. Understood? Okay. The last sum of this exercise. If a train runs at 60 km per hour, it reaches its destination late by 15 minutes. But if it runs at 85 km per hour, it is late by only 4 minutes. Find the distance to be covered by the train. So we are going to talk about a train, the distance it is going to travel and the time taken. Okay, so first let us take the distance to be covered by the train be d. Okay, distance is denoted by d. Now we are going to use a formula, time taken is equal to distance by speed. This formula we are going to use it and we are going to find what is the distance covered by the train. So there are two cases, one if it is traveling at 60 km per hour, and the other case that if it runs at 85 km per hour. So first I am going to take it as first case. So in the first case the speed is at 60 km per hour. So if a train runs at 60 km per hour, it reaches its destination late by 15 minutes. So usually it reaches the distance, but if it is traveling at a speed of 60 km per hour, it is reaching the destination, okay, by 15 minutes late. So this is the first case. Now time taken is 15 minutes more than usual. Okay, more than usual, it is taking 15 minutes more. Now we are going to take it as convert the minutes in hour. So remember that we have to convert the minutes into hour because the speed is given in terms of kilometer per hour. So minutes is converted into hours. So how do you convert? It is by divide by 60. Yes, 15 by 60. So here time taken, t is the usual time. Let the usual time taken be t hours, and it is 15 minutes more, right? So t plus 15 by 60. It can be written as 1 by 4 r. Now using the formula distance by speed equal to time. Okay, so what is the distance we are taking as d by what is the speed it is traveling? 60 kilometers. So d by 60 is equal to time. So time is, usual time is t, but it is 15 minutes late. So t plus this 15 by 60 is already written as 1 by 4. So t plus 1 by 4. So this is how we write it. Now in this we are going to cancel the 60 which is in the denominator. So multiplying by 60 on both the sides, d by 60 into 60 gets cancelled. So you balance have d in my left hand side. In my right hand side, when I multiply by 60, it is expanding as 60 into t plus 60 into 1 by 4. Yes, now again you substitute expand it. So 60 into t is 60t plus 60 into 1 by 4. 4 and 60 gets cancelled. 4 1 times, 60 15 times. So what is the answer? Final equation are getting d is equal to 60t plus 15. That is the first equation from case 1. Now we are moving to case 2. In this case 2, the train is traveling at the speed of 85 kilometers per hour. And it is late by only 4 minutes. So now this 4 minutes has to be converted into hours. Remember that. Okay. So time taken, usual time is t, plus it is 4 minutes late. So 4 by 60. 4 by 60 can be written as 1 by 15. Yes. So that is what I have written. Time taken is equal to t plus 1 by 15 hours. Now using the formula distance by speed equal to time, distance is d, by speed is how much this in this case 2, 85 kilometers, that is equal to t plus 1 by 15. Understood? Now to remove the 85 in the denominator, multiply by 85 on both the sides. So what you will have? D by 85 into 85, that is equal to 85 into t plus 85 into 1 by 15. 85 gets cancelled in my left hand side, therefore d is the balance one. And in my right hand side, what I am having? 85t plus 85 and 15 using 5 tables. 85 17 times, 15 3 times. So you have the final equation as d is equal to 85t plus 17 by 3. That is the second equation. So I am going to take the first and second equation. I am going to solve it for t. Now in the previous one equation, when you look at the previous equations 1 and 2, both my left hand side are d. So since both are d, I am going to equate 1 and 2. So when I equate, what happens? 60t plus 15, that is the first equation, right hand side part. Yes, 60t plus 15 is the equation 1, right hand side part, and 85t plus 17 by 3 is the right hand side of equation 2. Both I have equated because both the equation d is the left hand side. So I am equating and eliminating d. So this is what is the equation I am getting. Now I am going to transpose the values. So transposing the constant term to the left hand side, I get 15 minus 17 by 3, that is equal to 85t minus 16. So when I take the LCM, it is 3. Numerator becomes 45 minus 17, that is equal to 85 minus 60 becomes 25t. Then cancel, subtracting, you have 25t by 3. 45 minus 17, when you subtract it, it is 28 by 3, and to the right hand side you have 25t. So now keep the t as it is, transpose 25 to the other side, therefore that becomes t is equal to 28 by 3 into 25. So when you multiply, 28 is the numerator, 3 into 25 becomes 75. You keep that as it is. Now this value t we are going to substitute in the first equation, that is d is equal to 60t plus 15. So in the place of t in equation 1, I am going to substitute 28 by 75. So 60 into 28 by 75 plus 15. Now multiply 28 into 60, that becomes 1680 by 75 plus 15. Now this value 1680 by 75, and why I am doing multiplying by 60, it is since it is in minutes, I am multiplying, converting into, yes, what I am doing, yes, conversion of hours into minutes we are doing. Yes, 28 by 75 into 60 plus 15. Okay, so that is why we are doing into 60 over there. Now this 1680 by 75, when you divide, it becomes 22.4 plus this 15, adding up it becomes 37.4, which is the distance the train has to cover. Okay, so this is the end of exercise 3.7. please go through your notes, write it down, ask any doubts to your class subject teachers, and the objectives after this is given as homework. Do try them and clear your doubts. All the best, children. Thank you. Goodbye.